Hello, Algebra 1. This is Mrs. Hausman with the notes on growth and decay. So in this lesson, we're talking about the rising cost of colleges. Let's say the tuition at the University of Pittsburgh was $12,000 in 2014 and goes up by 3% every year. What would the tuition cost in 2019? The first thing that we have to remember is how to calculate 3% of an amount of money. So one of the things that we did back in chapter 2 was we changed our percent into a decimal, 0.03, of meant to multiply, times our amount, which is 12,000. Now, this would give us 360. Just double check that. Yeah, and that is how much money it would go up by. So if we wanted to find the total price of tuition in 2015, we would have to take the 12,000 and then add on our 360 to get 12,360. There is a much faster way of calculating this, and that is also what we did in chapter 2. We were thinking about this as we want 3% of the amount, and we want the original amount. So one way that we can do this is by multiplying by 1.03 of the amount. And so if I would have taken 12,000 and multiplied it by 1.03, I would get the original amount plus the extra that the tuition has gone up. So that is a nice way of thinking about it, to just simply multiply by 1.03. So if I continue that pattern, if I multiply by 1.03, what's interesting here is that it's going to go up by 3% on the 12,360 price. So when I multiply by 1.03 again, the new tuition will be $12,730.80. If I multiply by 0.03 again, I will get 13,112.72. Multiply by 1.03 again. So we can continue to do this to see what the price would be each year. $13,056, and that's 11 cents. And then finally, do it one more time. We will get the final price here to be $13,911.29. If we want to do 2020, we could multiply again. And in 2021, if it's rising at 3%, by 2021, it should be 14,000. The thing is that if you actually look up the price for the tuition at Pitt, it's roughly around 19,000 for 2021. So the price of college is exceeding the price of inflation. Usually inflation each year is roughly around 3%. And that's a little bit of a concern because college prices keeps increasing, but the wages and other items do not. And so this is an interesting problem of growth. It's going from 12,000, and we can model this with the equation that my beginning amount is 12,000, and I'm multiplying by 1.03 a couple of times. If I want to find the price in 1, 2, 3, 4, 5 years from now, all I would need to do is take my 12,000 and multiply by 1.035 times. A quick way to do that is through exponents. When we have repeated multiplication, that's a power, and that's a nice fast way of coming up with this $13,911.29. So this is called exponential growth. and we actually have a formula for it. The formula has some type of beginning amount, which is called A. A is your initial amount. You have some rate. Now we do change that rate into a decimal. We use the letter R, and I'm sorry it didn't copy very well in your packet, but if you want to go ahead and write that in. And it depends on time, how many times you are going to be multiplying it. So it's y equals, I'll write it right here, y equals A times 1 plus R, plus because we're growing, we're adding on for the base every time. Let's try it with this population example. The population of Johnson City in 2005 was 25,000. That is going to be our amount in the beginning. That's how many people we have. So we're going to be filling that in for A. Since our population has been growing at 3.2% each year. Now, this 3.2% is our rate, but we want to change this 3.2% into a decimal. Remember, percent means per 100. So 3.2 divided by 100 is going to be 0.032. That is the number that we are going to use for our R right here. We want to write an equation for this. So in part A, we would write y equals 25,000, that's how many people we begin with, parentheses, 1 plus our rate, which is 0.032, raised to the t being our time. Now we can then use our equation like we did right here. It says, what is the population in 2015? So from 2005 to 2015, we can calculate the years to be 10 years. We can use our formula and replace the t with 10. So our equation becomes 25,000 people. It's rising at 3.2% each year for 10 years. So in our calculator, we could go ahead and type 12,000 parentheses 1 plus 0.032. For order of operations, our calculator will add those bases together first before it raises it to the 10th power, and then it will multiply by the 12,000. So that means that we will have 16,444, I'm sorry, 16,442.8. We're just going to round it down to, we're talking about people here, so we don't have parts of people, thank goodness. We will just round that to the nearest person. So 0.89 of a person, we're not going to count them. We're just going to count the whole people. All right, let's take a look at example 2. So of course, when we're talking about interest in banking, typically we would like for all of our interest, at once. That's called a simple compound formula, which is what we were doing just then. If you see the word annually, annual means once a year. Now, banking and banks do not use annual that often. Typically what happens is this. Let's say I have $100 and I lend it to the bank. I put it into the bank to save. The bank will take the $100 and they will lend the money out to someone who has a loan. They might get 5% interest on a loan and then give you 1% interest back for your money. So like if you have your money in the bank and you're earning 1% on that money, you're not making a whole lot of money, but the bank makes money in this transaction back and forth. They have to give you some interest for you having it in their banks, like paying you back for using your money to lend, right? So that's kind of how the banking system works. Now, they may not want you to give you this whole percent all at once. I mean, maybe your account fluctuates up and down. So they might give it to you annually. You might hear semi-annual. Semi-annual means that they do it twice a year. Quarterly is another way you might hear it. Quarterly is like it sounds, 4 times a year. Monthly. Typically, my bank does it monthly. You'll get a monthly interest of how much money, extra that they give back to you in interest. You might also see daily. It's rare, but it does happen. Daily would be 365. So these are all ways that we could compound the interest over the year. So this is going to be our values for n, where n is the number of times that the interest is compounded during 1 year. Now, it's kind of interesting. What they're doing is they're taking the rate that we would have and they're dividing it up a number of times. So if I divide it up over 4 times a year, that means that if I'm doing it for 5 years, 4 times a year, that increases my power right here. And so it kind of changes the amount. Let's take a look at this example. We're going to kind of go ahead and do it and try to look at the difference between doing it quarterly versus doing it annually, and we'll see what happens. So in example 2, it says determine the amount of interest if $500 is invested. That $500 that is invested is oftentimes in business called the principal amount. That's how much money is going into the bank. So this is going to be our P value. We also have our R value here of 4.25%. Remember, we're going to change this R into a decimal. So 4.25 divided by 100 will be 0.0425. They're going to compound this quarterly. So the word quarterly is telling me my N value, which in this case is going to be 4. And they're also telling us our time, which is years. We have 12 years. So if we're following the formula here, we are going to be investing $500, 1 plus my rate, which is 0.0425, but they're not going to give you your rate all at once. They're only going to give it to you 4 times a year. So we can go ahead and divide that up over 4. Now, if I give you the interest rate 4 times a year for 12 years, that means I'm going to be doing it 48 times. And so if you do this right here, this $500, 500 times 1 plus. Now, you don't need parentheses here because order of operations, your calculator will divide by 4 before it adds to the 1. And then when you raise your power here, you would either have to put parentheses around the 4 times 12, or you could just type 48. I'll do parentheses and show you what 4 times 12 looks like as a power. All right, so that means after 12 years, your money would grow to be $830.41. Now you might say, well, what if I only got it annually, once a year? Well, that would be 500 times 1 plus 0.0425. That would be the simple formula that we did in the last one, doing 12 once a year for 12 years. If n is 1, you wouldn't get as much money. The more you compound, the more money you would get. That's kind of one of the reasons why they don't let you pay your taxes just once a year. You're not allowed to go on April 15th and give you your money right off the bat. The minimum that you can do to pay your taxes is to pay quarterly. But actually, what they do is they take it out of your paycheck, and most people get paid every other week. So if you get it weekly, they're taking it out 52 times. If it's bi-weekly, then you're getting it taken out 26 times, which means that the government has your money and is getting interest on that money more often. Power of the compounding. So it's a nice little formula, though, as long as you can figure out what your R is, how you're compounding, and what your time is, and your principal. When you plug those numbers in, calculating it is not too bad. The last thing that we want to discuss is also how you can use exponents to show decay. Exponential decay, remember, is when it decreases over time. And so this would occur whenever, instead of 100%, we take off our rate. It's losing a certain percentage every time. A great example of that is a car. A new car here costs $32,000. This amount that they're giving us is our principal amount or initial amount. You can call it either or. We're going to call it A for this formula here. It's depreciating at 12%. 12% is the rate, and remember 12 divided by 100 is 0.12, so you're going to change your percent into a decimal to use the formula. We're going to do this for each of 4 years. So time equals 4. Then what we're going to do is depreciate it 8% each year after. Find the value of the car in 6 years. Let's do one step at a time. First, what we're going to do is start with our $32,000. We are going to take off 12% each year, and we'll do that for the first 4 years to see what the price of the car would be after 4 years. So if we take 32,000 times 1 minus 0.12 raised to the 4th power, that car will be worth, after 4 years, it will be worth $19,190 and a quarter. Okay, now, after that, because if you really want a new car and are trying to get a new car, it drops in value right away, because the moment that you take it off the lot, it is no longer new. It's a used car. But used cars tend to hold their value because a lot of times people like to buy a used car. It's more affordable, or if they're buying it for a new driver. So we're going to start with this 19,190. Undo that real quick. Pen is being a little bit odd today. So 19,190 and a quarter. And it's still going to depreciate, but it starts to depreciate a little bit less. It starts to depreciate at 8% for the next 2 years after. Kind of holds its value. It's like got enough miles and it's still usable, and a lot of times people will pick it up at that point. So if I take that 19,190 and a quarter, multiply that answer by 1 minus 0.08 for the next 2 years. You can either use square or caret too, either way. That car will then be worth $16,242.63. We can round our money to the nearest hundredth. So you can use exponential growth, decay, and compound interest in a variety of situations in real life. The first thing that you want to figure out is, which formula do I want to use? So in this one here, we're talking about investments, and we're investing a certain amount of money, $300. That's my principal amount. We have an interest rate, so they're giving us our R, compounded semi-annually. So here we're breaking it up not once a year, but twice a year. So for 20 years. So in this problem here, I would say the best formula to use is that the amount is P times 1 plus R over N raised to the NT. Once you know which formula you're going to use, you can go ahead and start substituting in. My principal is 300. My rate is 6.75, which, remember, if we divide by 100, will be 0.0675. Fix that right there. 0.0675. Divided by our semi-annually, that's our N. And if we're doing it twice a year for 20 years, that means you're compounding it 40 times. So after you plug everything in, you can use your calculator. Remember that you don't need parentheses on the inside here, because 0.0675 divided by 2, order of operations in your calculator will take care of. 2 times 20 is 40. I'm just going to put the number in to save some time. So that's going to grow to be $1,131.73. All right, let's take a look at example number 2. Housing. So in this time, we have a condominium that is worth $110,000 in 2010. The value is appreciating, so this is going to be a growth. It's going up in price at a rate of 6% per year. I'm going to change that rate into 0.06, change it to a decimal. What will the value be in 2015? Now, this requires for us to do some thinking. From 2010 to 2015, the time has gone by about 5 years. So we're going to use T equals 5. Now on this one here, it's just appreciating. So this is exponential growth. This would be the formula y equals a times 1 plus r raised to the t. So this would be initial amount of $110,000. 1 plus my rate is 0.06 for 5 years. So one of the things that they say is good to invest in is in real estate because it holds its value. Land and property typically do as long as you take good care of it. And this house here would appreciate to $147,204.81. So after 5 years, it does kind of hold its value. All right, in example number 3, a piece of machinery here depreciates. So when you hear that word depreciate, it's going down. So this is how much the machinery started at, and it's losing 10% yearly. So this is my R, which would be 0.10, and it's doing this every year. So that would be the formula y equals a times 1 minus r raised to our time. So we are going to start off with 25,000. That's the amount that we have. It's losing 10%. So that's my rate that's coming off. How much would it be in 7 years? So they're giving us our time, they're giving us our amount, they're giving us our rate. We're just going to go ahead and substitute those all in and then calculate. 25,000 times 1 minus 0.10, which is 90% of the price, gets held. So this machinery would be worth 11,957. Undo. Sorry about that. 11,957 and 42 cents. All right, my last example here for transportation, a new car cost $18,000. It's expected to depreciate. So in the Kelley Blue Book, a lot of times you can look up what the price of a used car is worth. If you're shopping for a new car or a used car, you can check it out. It's depreciating on an average rate of 12%. So this one here would again be the y equals a times 1 minus r. It's depreciating the same amount each year. So the amount that it starts at, that's your beginning amount or initial amount, that's your 18,000. It's depreciating at 12%. Make sure you change your rate into a decimal, 0.12. And we're going to find the value of the car after 8 years. That's going to be our time. So this is going to be 18,000 parentheses 1 minus 0.12 raised to the 8th power. So the car will be worth, after 8 years, $6,473.42. Then you can, negotiate and say, how much is my car worth at trade-in? A lot of times you can use that Kelley Blue Book to kind of look up how much your car would now be worth. Again, there's other things that go into it, the condition of the car, how many miles it has, if it's ever been in an accident or have body work. So there's lots of other factors, but a lot of times using this modeling, you could really get a good estimate of what something is worth in the future. Hope that helps. Have a great day, folks.